All right. Today will be a little bit more sophisticated than what we've done before. Yeah, I mean, it's inevitable, right? You learn the basics and then you learn something that isn't just the basics anymore. But I need to do this because what I'm about to show you is what's necessary to solve certain kinds of problems. And I want to make a connection, okay, between data of certain kinds and certain kinds of logical structures in Python that are just like the right ones to operate on that data. We'll get to this later on. We'll start to have projects at the end of chapter 4. It's not really until the end of chapter 4 that you know enough Python to take on like a project that would be worth your time. But after that time, you will. And at the end of the semester, we'll do this image filter project, where what you do is you'll write literally filters for digital images, so you can like alter them, like expand them, contract them, rotate them, change color schemes, some or another, like make grayscale. And that is ultimately operation on a two-dimensional data set, okay? Because a digital image is composed of pixels in a two-dimensional array, and the pixels are ultimately defined by just numbers, 5 total actually. A pixel has a position given by an x and a y coordinate, and then it has a red and a green and a blue value. So if you give the coordinates of a pixel together with its red and green and blue value, which sort of merge to give it its color, then you have completely defined the pixel. So a digital image is just a two-dimensional array of groups of 5 numbers. I mean, from the computer's point of view, that's all that it is. Everything, ultimately, from the computer's point of view, is just a collection of numbers, and all your computer really is, sort of internally, is just this really fast calculator, is what it does. But the point here that I wish to make is that data will be ultimately like two-dimensional, okay, or at least two-dimensional, because the pixels occupy this two-dimensional grid system, right? And there will be just the right way to like get through them, okay, which is exactly what you'll have to do if you're going to like apply some filter to the image, right? You've got to go through every pixel and build a new image based upon what you find, okay? That's what we'll actually talk about today. We'll talk about the sort of logical structure in Python that makes it possible to get through a two-dimensional array, okay, like an image where you've got rows and columns, right? Okay, now, before I hop into that, I want to introduce another word here. It's a good word to know. And what we're about to see will be an example of this. The word is compositionality. Big word, I know, but I think it's important to understand the idea behind it. It's an important computer science idea. And the basics of the idea is this. Okay, so we've got these logical structures, right? These ways to write code. The first one that we encountered was really the function. Okay, that was in chapter 2. And then in this chapter, we now have iteration. Okay. Now, what I mean by compositionality is that these logical structures can be like embedded inside of one another. You can compose them. You can put them together. So could you, if you were to hop back to chapter 2, could you put a function inside of a function? Absolutely. Okay. I mean, that's just something that absolutely any language would allow. So I'm just going to do a really quick example here that will be kind of silly. So what I'm going to do is define a function inside of a function. Okay, so I'm just going to define like the square root function inside of this function. And I guess I'll use another variable, call it x or something. And then I could just return x to the 1/2 power. And then what's happened is that I have now defined the square root function inside of my example function, and I can make use of it if I want to. So I tell you what, I'll make my example function have 2 input values, so it'll be like, I don't know, Pythagorean theorem, it'll get the value of c. And then what's it going to do? It's going to return a squared plus b squared, and then what it's going to do is it's going to call the square root of that, or take the square root of that, which means that it will call the square root function that has been defined. I'll run it to make sure it works, but the point I wish to make here is that you can compose functions, okay? You can absolutely put a function inside of a function. You could put a function inside of a function inside of a function, okay? And this is something that maybe it's important to make the connection here that the English language allows you to do. It allows you to put like sentences inside of sentences inside of sentences, or rather like to build clauses into sentences. Like, I don't know, the girl hit the boy. The girl hit the boy that hit the girl. The girl hit the boy that hit the girl that hit the boy. That can go on forever, right? And each time you get a new statement, and what you do is you like take what you had before and like compose it, You put another copy in there. You can absolutely do that. So let's run this. And our x func, which is really, I guess, the Pythagorean theorem calculator, if I've done everything correctly, it'll return 5, and that's what it absolutely did. So, compositionality of functions. You can put a function inside of a function, okay? Now, this chapter is about iteration. It's another one of those sort of basic logical structures in Python. Usually an indication that you've got some like new logical structures, you've got new keywords, and that's absolutely what happened in chapter 2. We got def and return, and then this chapter we got for and in. Okay, so we use those to create this new logical structure that we call iteration. You can compose those as well. Okay, you can put an iteration inside of an iteration. You can put an iteration inside of an iteration inside of an iteration. Or if you want to use the language of loops, for loops, you can put a for loop inside of a for loop. You can put a for loop inside of a for loop inside of a for loop. You can go as deep as you want. You probably never go any deeper than 3, but sometimes you need to. You need to compose iteration. Okay? And I'm about to show you how that works. So here we go. I'm going to write a really simple example of this. And ultimately, all this function will do is just print some values. I don't even need it to return a value. I just need it to print some values. So I will do that. So this function called iter, which is short for iteration. That is, I'm about to compose iteration. It takes a single, oh, no, I think I'll do it slightly differently. Let it take 2 numbers, and then it will use one of those to define the first iteration, the outer iteration, let's say, and it will use the other one to define the inner iteration. So here we go. How do you start an iteration? What's the key word? For. These are for loops. For, and then we need some loop variable, which is our choice. It's very common to use an I for a loop variable. I know we've got a programmer out there, so you've typed I lots of times for these contexts. The next one after that, if you've got iteration inside of iteration, is often J, and then after that it's often K, and probably you never need to go any deeper than 3. If you think you do, you probably should rethink how you want to solve your problem. But here we go. For I in, all right, m and n are integers, okay? But you know that for loop needs a sequence, in this case a list, and that's what the range function does for us. So let's just simply do range m. And you, of course, remember how range works when it is given a single argument. That's the what value. Stop. Start defaults to always 0. Computer science would begin at 0. Step defaults to 1, and the Price is Right rule is always in effect. That is, we never actually reach the stop value. So, for instance, range 12 is 0 through 11. Okay, that's important to know. You won't be able to solve the problems of this chapter unless you are quite clear about how it is the range function works. All right, so colon, and then of course now we're indented again. Notice that really we've indented a second time. Line number 8 was the indentation for the body of the function, and now line number 9 is the indentation for the body of the for loop. Okay. So here's something we could absolutely do if we wanted to. We could start up another for loop. Why? Because you can compose iteration. You can iterate iteration. So how about for j in range n? Okay. And then all I will do, if I could type this up, is print the values of I and j. Okay. You know that those are the loop variables, right? So you know that they will step through the items in their lists. So I will step through range m, and j will step through range n. And the crucial point here is this, okay? Whenever you have iteration, the body of that iteration must completely execute before we loop back and perhaps do it again, right? I mean, that's just the basic rules of iteration. Well, in this case, the body of the I loop is itself another iteration. It's the j loop. So the j loop would have to completely execute. That is, the j would have to go through all of its values before we would go back and have I go to its next value. And you can absolutely see this. Okay, so let's watch this happen. So iter. So iter, how about with 3 and 4? Okay, so we'll have a range 3, which is 0, 1, 2. We'll have a range 4, which is 0, 1, 2, 3. And then watch what we get. Okay, Look at the pattern in this. And notice the left column is the I value, the right column is the J value. So apparently what happened is that I was stuck at 0 while J went through all of its values, 0, 1, 2, 3. So you see that first chunk of 4 pairs, right? That was the first time that the body of the I loop, which is the J loop, executed, okay? So I was 0 throughout all of that, and J went through 0, 1, 2, 3. And then once it hit 3, the J loop was done. That means that we could go to the next value of I, which would be 1 there on the left-hand side. And then once again, the J loop would completely execute. So that J loop completely executes once for each element in range M, right? So the conclusion then is that that for long J loop has to complete 3 total times. That means that the total number of times that the print command was executed had to be 12, okay? It had to be 12, and that's iterated iteration. Now, let me begin to show you some of the work that iterated iteration can do. Let's say that we had a data object like this, okay? Well, I'll type it on the console in just a moment. Let me describe it first. A list of lists of numbers, okay? You know that you can create lists of numbers, of course, but you can create lists of anything at all. So you can create a list of lists where those sublists themselves contain numbers. Now, here's something you might have to do, and that's a very natural way for data to come. Data is very often packaged up in that way. So something that you might have to do is like, very simple task, go through and add up all those numbers that are in the sublists. Well, how would you do something like that? Well, first of all, you have to iterate through all the sublists in the list. That's the outer loop. And then you have to, for any one of those sublists, you have to iterate through its elements, okay? That's a double iteration. That's an iteration inside of an iteration. So let's actually write this, and then we'll talk about how it actually works with a particular example. So let us write, I'll go ahead and write, this can be useful to us when we go to the console. So let's write a bit of code where we simply create a list of lists, okay? So how about it's 3 and 4, that's the first element, that's the first sublist, and then how about -1 and 0 and 3, and then how about finally just a single element sublist, that would be 4, okay? So on line number 12, that's a list of lists, okay? That list contains 3 elements. The first element is the sublist, 3, 4, the second is, and so on. Now again, what we want to do is we want to be able to take a data object like that, dig in, and pull out all the numbers and add them in, and add them together, okay? So here we go. I'll call the function something like, sublist summer, or something like that. I'm not sure what a good name is, but there we go. And then what that'll do is it'll simply take some list. Let's call it capital L. I'll sometimes start to do that. If I need to designate a sequence type object like a list, I will often do that with a capital letter. And it's clear what the L designates in this case. That means a list. So here's what we need to do. What we need to do, first of all, is iterate through the sublists, okay? And then once we've grabbed one of those sublists, we have to iterate through the numbers in it. And those have to be added into some variable, okay? So how about I create the variable, some element, and this is that same pattern that we talked about last time, right? Where you initialize the value of a variable and then you enter into iteration, and as you iterate, you update the value of the variable, and then finally you just return the value of that variable once all the iteration is complete. So that basic structure is still here, but what we'll have now is iteration within iteration. So for sublist in L, now what will that do? Well, if L is that list that I created on line number 12, sublist's first value will be the list 3, 4. Its second value will be the list -1, 0, 3, and then its final value will be the list 4. Okay, so this line number 16, well, it will begin an iteration that will occur 3 total times for the list on line number 12. All right, so sublist will now be one of the particular lists in our list of lists. And what we have to do at that point is we have to iterate through that sublist. So how about for, I don't know, num and sublist? And notice we don't need the range function here. The range function is to take an integer or integers and create lists. We assume, in this case, however, that we already get lists. Okay, so we've already got them, so we don't have to create them. All right, so we've been able to dig into the numbers in one of these sublists, and then what we have to do is we have to add that back into sum of elements. And I will use that bit of syntactic sugar that I talked about last time, that plus equal symbolism, which simply means increment the value of some elements by the particular value that I'm about to give you, which is num. And then we should just be able to return the value of some elements. All right. So let's run and see what we got. We will not be dismayed if we get a syntax error because we know that those are common. Well, apparently no syntax error yet. I think you knew this, but let me note that if you give a value to a variable with global scope, we talked about the difference between global and local scope. Local scope for us is the scope inside of a function. Global scope is outside of a hidden function, which will mean all the way to the left. That variable assignment on line number 12, that's global scope. That means that we can simply type the name into the console and we will see the value. So, yeah, there it is. So let's call sublist summer on that particular list. Let's see if that's correct. That should have summed up all the numbers. Okay, so 3 plus 4 is 7, minus 1 is 6, and then the 3 is 9, and then, yeah, that's it. That's 13. And I tell you what, here's something that I recommend to you. It's extremely useful, especially as the functions that you're expected to write become more complex and harder to write, harder to get right. Put print statements in to track the values for the variables. Because otherwise it can be very difficult to know what it is that your code does, okay? And this is something that I'll do to you, no doubt. You'll have some code, it doesn't work, you bring it up, I'll look at it and I'll go, I don't know why it doesn't work. And then what I'll do is I'll start to insert print statements so I can see the values of the variables, see what they are at a particular moment, see how they change. That will very often give you an idea of how your algorithm works or does not work. So how about this? I'm going to print some stuff. I'm going to print the sublist, and I'm going to print the number, and I'll go ahead and print the sum of the elements as well. That is, I'm going to print all the variables that are present here, and I'm going to run the code again. And that might help to understand what happened here. So sumlist summer on list. Okay, so it's a bit like what we saw last time, right? So the left-hand column stays constant for a bit. First 3, 4, and then 3, 4 again, and then it switches to negative 103, negative 103, and then, well, 4 only occurs once. Yeah.
It's having a syntax error in the first area, and if I just replace it with a regular variable name, it then switches the error to the defined set.
There is some character that you have not typed in correctly. If you were to examine your code, no, it's not. So I can find it for you if you want, but I absolutely guarantee you, I bet my life and the life of everybody in this room and everybody on this planet as well, that there's a syntax error with me. So.
It says, when it shows the error message, it shows an error.
It says invalid syntax. So.
It shows the error under first when it says syntax error, so I believe it meant that first.
You started your variable name with a 1 instead of an L.
Huh?
Remember the variable name rule? You cannot start with a number. Okay, that's an L right there. And that's actually kind of evil. For the most part, I don't use lowercase L's because they almost look exactly like ones. I apologize that I did that. But that is an L. Okay, that is an L. Short for list.
And after that, though, it then switches the errors to some elements, saying some elements is assigned but never used, and some elements.
I will tell you again. There is some character in your program that is different from the one that is here. And that is your task to find that out. Okay, that is your task. All right, so you see what happened, right? the first value of sublist, the outer loop, was the list 3, 4. Good.
Made a typo.
Was 3, 4, right? And then let's see, I saw num and some elms. Okay, so the particular elm was 3, and that was added to 0 to give me 3. And then the next line, the elm that I picked out of 3, 4 was the 4. And then that was added into the sum, which was currently 3, became 7. And then with that, I was completely done with the inner loop because it only had to go twice. So we went back to the outer loop, and sublist got its next value, which was the next sublist and the list of lists. And then we went through its values and added them into some elements. This is what iterated iteration can do for you. And let me do point out that the data structure right here, the data structure that I have on my number 12, that's really an array, okay? And the best way perhaps to show why it is an array is to list it like this, as a row, as a list of rows, okay? First 3, 4, and then negative 1, 0, 3, and then 4, okay? So we have 2 dimensions in that, okay? We both have rows and we have columns as well. That's a 2-dimensional data structure. A list of lists is 2-dimensional. And anything that is 2-dimensional, probably the way that you will need to get through that is with iterated iteration. And notice the way that it went. The outer sublist iteration, that stepped through rows. And once we grabbed a particular row, we stepped through the columns in it. And then we went to the next row and stepped through the columns in it. And then to the next row and stepped through the columns in it. That's typically how you do this. When we do the image filter project, that's exactly how we will do it. That is, the outer iteration will choose a row, and then once the row has been chosen, we will iterate through all the pixels in that particular row. And then we will go to the next row and iterate through all of those. 2 dimensions, iteration inside of iteration. They go together, okay, always. All right, so with that, I think I'll stop. And